J van Geven or Jeep Water to share the screen and share that slide. And there was Tladi, I can't remember Tladi or Kekana. So I want you to continue, at least have a discussion on two problems. Currently, I'm attending another meeting here on Teams, and then there's somewhere here and there I have to comment, but I've just asked them to be excused so that I can just inform you. Yeah? So I'm gonna be in the meeting. Just go to the last problem. Mr. Van Heaven. Not that one. Kekana, are you here? Yeah. Is it this one? It looks so, yeah. Kekana, are you here?
Yes, sir.
Okay. Clady, are you here?
Yes, sir.
Okay. Yeah. Whoever has done this problem, but I'll just ask Kekana again, or must I ask who? Let's see. Kekana.
Sir?
Jay Van Heaven will be the chair and the screen controller, and then you will be the one who will do the talking, and then those who will comment. You will lead, and then those who will comment, they'll comment from you. Otherwise, if you want to control the screen, you can tell Jay Van Heaven to stop and you control the screen.
Hey, sir, can I ask if there's anyone else who did it so that they can help where I stuck?
Yeah, no, it will be a discussion. That's why I'm recording. I'm just after this meeting, I'm gonna come back and see what was happening and how you have handled it. And I think from this, I'll be able to say next during those sessions whether you'll be able to this can work without me being in the group or not. I don't know if you get me.
Okay, sir, no problem.
All right. Yeah. I'm just gonna go back to the other meeting. You'll see I'm gonna still be online, but maybe it will say something on your side, but it will show that I'm online, but I can't hear what you are saying. I can't even see what you are saying. So if you decide to ask a question, I won't be able to respond because I'm attending the other one.
Sir,
Yes, sir.
I just want to know, did you get maybe some questions that is similar maybe to the questions of the test that you can give us the exercise on or not?
Uh, I was trying to ask Mr. Fuamba today. So it's just that since morning, we've been, it was just meetings back to back. We are dealing with the backlog. There are guys who are doing the projects who failed the project for is it last year? Yeah, the project for last year. So we've just given them a chance to represent their staff today. So everyone was just busy today. But I'm gonna try and talk to him maybe later tonight. And then if he agrees, then maybe tomorrow you can have those questions, similar problems.
Okay, thank you, sir.
Okay, thanks. Yeah, so I'm gonna excuse myself, and then Mr. Van Geven and Kekana, I'm leaving this in your hands. So I'm gonna come back later and watch the video.
Hey, sir, can I ask me,
Yes,
is Mr. Van Kreven understanding this thing, the
understand.
problem?
I have no idea, so it's fine. You can do the discussion there, and
Oh, all right, because I don't want to speak alone, sir.
no, you'll not be alone. There is how many people here? There is almost plus minus 44 people here. So
Okay, sir.
yeah. So that's where we'll see if you can be able to work in the team team as a class or not? Okay, thank you. I'll catch up with you later.
Okay. I hope you guys can hear me. Miss.
Yes.
Oh, all right, cool. So I don't remember what the question was asking for. Oh, it was asking for OX, OY, and OZ, right?
Yes.
Oh, okay. So, oh, is that a question? Oh, that's the one. Eh? All right, cool.
Yeah, that's the question.
Oh, okay. So they say that the light right angle boom, which support the 400 kilogram cylinder, is supported by 3 cables and a ball in a circuit joined at O attached to the vertical X and Y. Determine directions at O and the cable tensions. So we know that directions at O is OX, OY, and OZ, right? Okay. We can go to the solution then so that I can explain. Okay, sure. So we draw, first thing you draw the free body diagram, right? And after that, you see that we're having tension AC, BD, and BE. And we also have OX, OY, and OZ. And it doesn't matter where you place your OX or Y or Z, right? Because of the sign is the one that's going to tell you whether OX goes away or towards the x-axis or OZ or OY, so on and so forth. Okay, first thing first, we need the unit vectors of the tensions TAC, TBD, and TBE, right? Okay, so you can see that at the top there, TAC, right? They say TAC, they found the unit vectors of TAC, right? In terms of I, J, and also K, right? So you firstly find the coordinates. We know how to do that. So you firstly find the coordinates between A and C. I don't know whether you understand that, how to get the coordinates, or you find the distances between A and C for the tension TAC in the x-axis, in the y-axis, and then in the z-axis as well. So they found that for TAC in the x along the I, which is the x-axis, is -1 between AC, and then in the J it's +1, and then in the K it's 2. Then they divided that by the magnitude of the unit vectors, right? Right? Or am I speaking alone? I don't know.
Yes.
Am I making sense?
Yeah.
Oh, okay. Okay, sharp. And then we have how many tensions? We have 3 tensions, right? We have TAC, TBD, and TBE, right? So the other one for TBD, right? For TBD, they also found the unit vectors of I, J, and K. But then we only found that for TBD, there's no I. That means there's nothing along the x-axis. There's nothing along the x-axis. There's only I. There's only J and K. The I is 0. Hence, there's no I there for TBD. Right. Then for TBE, there's no I, and then there's no J. If only I can write this, but then it's fine. So for TBE, there's only K, right? And then we go to that principle that the sum of X is 0, the sum of Y is 0, the sum of Z is 0, the sum of the moment along the x-axis 0, the sum of the moment along the y-axis 0, the sum of the moment along the z-axis equivalent to 0. So for the sum of the moment on the x, we look at the I. At the I, you resolve your tension into I, J, and K, right? So you only to find out that for the x-axis, all the forces, all the vectors that are acting along the x-axis. So we only find out that it's only OX and only -0,408, which is the I for TAC. Remember that TBD doesn't have an I, and then TBE doesn't have an I as well. Hence, you can see that it's OX minus 0.408 TAC, right, for the first equation. I don't know whether you understand or... Mr. Van Geven, am I making sense, bro?
Yeah.
Okay, cool then. And then also for the Y, we look at the J's, right? The J's, everything that's happening along the Y-axis, right? Which is OY that you can see on the diagram. You see that there's OX, OY, and OC, OZ. So for the Y, for the sum of the Y, we look at all the forces that are acting on the Y-axis, which is OY, and then which is 0.408 TAC, right? For the J, for TACJ, you see that. And then for TBD, there's 0.707, which is acting along the J. And then remember that we have the weight of an object which acts along the y-axis. That's why there's 3,924 there. That is the weight that is acting along the y-axis, right? Then we have our two equations. Then we can do all the forces that are acting on the z-axis. On the z-axis. So on the z-axis, all the vectors along the k, which is OZ, right? OZ, which is acting upwards, which is OZ. And OZ is acting along the z-axis, because then you see that it seems like they swap the x, y, and z axis. The z axis, it's where normally they place the x axis, and then the x axis is where normally they place the y. And then I don't know whether it makes sense or what. But then other than that, along the z axis, you see that it's OZ, and then also there's minus 0.816 on the K. If you can look at TAC, the tension on TAC, the minus 0.816 is acting along the C axis, and also the 0.707 TBD is acting along the Z axis, and minus TBE along the Z axis. So for you to get these equations, you have to find the vector units along the tensions. You check your tensions, and then you compute the tensions into I, J, and K. If you can do that, then when you do the sum of X, you know that the sum of the X is I, the sum of the Y it's J, and then the sum of the Z is it's K. If you can do that, then everything's gonna be sharp. Then we go to the sum of the moments. I don't know if ever there's somebody who wanna explain this one, or I don't know.
But the sum of the moments is like almost the same. You just time it with the distance.
Yeah.
That's all you do.
So look,
Because you can see it's always the same. The minus 0.48 TAC times 2. 2 is your distance till O. Minus 0.701 BD, and that's also 2. And then your mass is 3924 times 2 is also your distance. I don't know. Yeah.
Basically, it's like that. Or you look at the vectors or the forces that are causing any rotation along the x-axis, the y-axis, and the z-axis. The values there are the same, but then we have to multiply that by the distance such that you're sure.
Can you go to moment at y? Ne? That one, yeah, negative 0.408 TAC. That 2, I want to know where did they get that 2? It's not supposed to be 1.
Which was
this one? She's talking about this one. The 2 there.
How did they get 2?
That one is 1.5 and the 1.5 is there.
Okay, for TAC, ne? Okay, I think it's because of you see the distance there. The distance for, if you can look at the origin O and Z. So, okay, the only way to do this, ne, do you know how to you know, into D, ne, if we had a force, I gotta recall do the components of that force, the f of x and then f of y. F of x and f of y. Similarly to this one, to the 3D, we can compute the TAC into x, y, and z. And you'll find out that if you can compute that into x, y, I, j, and k, basically I, j, and k, if you can compute that into I, j, and k, you'll find that along the y-axis, the minus 408, ne? TAC, it causes a positive rotation, which is the clockwise rotation with a perpendicular distance of 2 meters. I don't know whether you understand, because like I can't show you exactly.
You can take control. I think you can take control.
So you can see the mouse. Oh.
Yeah, I must go to the laser. Do you see the laser?
No, I don't see it.
There must be like a laser thingy under the paper or under the slide. Like there's a pencil, a laser, and then.
I can't see it. Can you do it for me?
Yeah, I must say stop sharing.
Where is it written?
There at the top. Oh, I think you stop sharing. Let me just go back here. Yeah, share content. Which do you only see the full screen?
Yeah, sure. I can see your screen.
Okay.
Okay. Nah, it's fine. Let me just explain then. Okay. Matap, can you hear me?
Yeah.
Yeah, sure. You see TAC, you see the tension TAC, right? Yeah. Like, can you like out of TAC, can you bring are you able to can you bring the X and the Y and the J components of TAC?
The what?
Yes, I can. X, Y, and Z again.
Yeah, X, Y, and Z.
Yeah.
Yeah, you'll find that at A, if you can do that, you'll find that the vector the vector which is the I, the minus 408 I, which is the I, it will cause a rotation along the x-axis with a perpendicular distance of 2. That's why there's 2 there.
Oh, I see.
Even
Okay.
even on the even on the moment along the y-axis, it does the same thing. If you can compute the TAC into x, y, and k.
Okay, I see. Thanks.
Okay,
But
sure.
why didn't they use with the BD also 2 meter? Only why did they use the 1.5 at BD? Because BD is almost like the same as TAC.
Wait, PD on along on the moments on at Y. The moments
Yes.
at Y.
Yes. And TB is also 1.5. Waar's Botha? Kan jy ons help? Gareth, can you help us?
Yes, sorry, what's the question?
Ooh, daai 2 en die 1.5. Where does that come from? The 2 and the 1.5. Why are they only using the 2 there and not there and there?
Let me quickly check. I don't know.
Because it's the distance, but at the top one we can see it's 2 because they're using it till the X axis and it's 2, 2 and 2.
Yes.
But for the Y is there. So I don't know. They're using a 2 and 1.5. So from there till the Y. Oh, okay, now I see the TBD and the TBE from here to the Y is 1.5.
Oh yeah, yeah. It's because of the 0.75 times 2. Yeah, yeah.
Yeah, then it's there. Then you get it till there. But why this one? Oh, I don't know.
Can I just interrupt there real quick?
Yes, you can.
Where is this moments taken about? These moments are taken about point O at point A, right?
Point O.
They're taken about point O, but
Yes.
at point A. Is that what's happening?
Yeah.
Yeah, so basically, hence the reason they're using 1.5 because of the 2 0.75 for both TBD and TBE.
Yes.
It's hence the reason they're using 1.5 because you're saying that these moments are taken about point O at point A.
They only taken.
You're saying that
point
these
O.
moments are taken about point O, right?
Yes. There.
But at point A. I don't know if I'm making
No,
sense.
man. You know what's going on there. You see TBD, ne? The K for TBD. Remember that you see along the z-axis.
Yes.
The TBD. You see that. So the perpendicular distance of TBD along the z-axis it's 0.5 multiplied by 2. Remember that TBD, ne? The K part, it's moving away, hence it's negative 0, 707. And then the perpendicular distance of TBD, it's 0.5 multiplied by 2.
Yeah, because there's also 1.5 there.
Yeah, sure.
1.5, 1.5. Okay.
And then again, TBD is gonna cause a rotation that is anti-clockwise. Hence, there it's positive.
Yes.
So for the z-axis, because you see that where the z-axis is at, normally where the z-axis it's x-axis. You see that?
Yes.
But then if you're to compute TBD into I, J, and K, but then since TBD does not have I, so if you can look at the K part, the 0.707 of TBD, it's going to cause the rotation of an anti-clockwise, which in this case is positive, with a perpendicular distance of 0.75 multiplied by 2. That's why they think it's 1.5.
Yes.
Yeah, sure.
Can I state my opinion? I think
Sure.
that for the moments at y, that 2 was a mistake, because if you're gonna use a 2, like you see the distance from O to C, the diagonal distance, that's the only 2 you can get, but you can't get moments at a diagonal. It's supposed to be perpendicular, so I think it was supposed to be 1. Does it make sense? Okay, you see the distance from C to O, that like if you go directly from C to O,
C to O, yes.
right? Isn't that would be 2 if you use the sine laws, and since both of the angles would be 45, since the triangle has 2 sides that are the same, that would be the 2. But that would be at diagonal, and you can't use that for moments since it's supposed to be perpendicular distance. So I think that they made an
No,
error
Megai.
since it was supposed to become 1.
No,
So
it's
that
not an
distance
error. You know what's going on, ne? It's not an error, da. Hence, like you see TAC, ne? Like if you're to compute TAC into IJ and K, you'll see that the I part, the negative 0.408. You see the 0.488, ne? It's acting along the x-axis. The x-axis, which in this case, the perpendicular distance of that x-axis of TAC, it's 2. From A, if you can look at A and AO is the perpendicular distance of TAC of 0.408. I don't know whether you understand.
The sum of the moments at y.
Yeah, sure.
And Kerry, if you're looking at the sum at the moments at y, for that first
Yeah.
one, the TAC,
Yeah.
why is that? And Kerry, her question was, why is it 2? And I still don't understand from your explanation, why is it 2?
Yeah. Hence, I was like, if you can like break TAC into its components, which is I, J, and K, right? You'll find out that if you compute this TAC da, ne, and then you project that component of X, which will be the component of TAC of X, which will be parallel to the X-axis. But then in this case, you're gonna focus on the moment along the Y, right? Right, ne? And then you'll see that as you break that TAC into the component of X as X, Y, and Z, ne? The X component of TAC is gonna cause a rotation along the y-axis with a perpendicular distance of 2. Thing is, I can't use this thing, bro. Like I was gonna draw it for you, and then you're gonna see what I was talking about.
Okay. I'll go work it out and see, because I still don't feel. I get what you're trying to say, but like I need to see it visually.
No, sure.
But it's
No
okay.
problem.
I'll try working it out.
Can't you use that laser thing? There must be like a laser where you can take notes, like there's a note thing. Do you see the note thing on the side?
Nah, I can't see. The only thing that I can see, it's take control and slide 13 out of 13, something like that.
Are you using a cell phone or a PC?
I'm using a PC.
Oh.
Just think here, because with me, it shows the slide a bit smaller and then it gives me notes and things.
Guys,
Now?
can I ask who's sharing the screen?
I'm sharing it, but
That's
someone
why.
take control.
Wait.
Someone took control of the screen now. I'm gonna. If you, I
Let me
think,
maybe take control.
take control.
Okay. Mhm. Yeah, there's no laser thing. Maybe the reason why you have the laser thing is because you're the one sharing this thing.
Yeah. Someone else can also share it.
Yeah.
They can say press there on the side next to your mic, share content, and then your stuff. If you want to do the laser.
But yeah, someone can share.
Who's the one that wanted to show someone else something?
Kikana, why don't you share so that you can show us what you meant by the thing?
Should I open share tray or something?
Next to your mic, there says stand share content. Then you click on it, and then you will see your chapter 3 equilibrium things there on the bottom.
Nothing as I can't see those things. The only thing that I can see is my camera, the mic, and then open share tray, more
Yeah.
actions.
You open that share thing.
And then
Do you see the chapter 3 live thing, equilibrium thing?
nah, I can't see. I can see. You know, as long as you can share your screen, and then as long as you can point
Yeah, okay, you must just tell me where to point.
with your.
Okay, so you can go.
Yeah. Okay. Can you point using your mouse something?
Do you see the laser?
No.
Really? On my screen it shows a laser.
Now mine it doesn't.
Something now?
Nope. But it doesn't matter though. It's fine. But then, can you break like TAC into the components of I, J, and K? So that like they see, or you know what, you can just draw. Can you like draw something, or like can you write something? I'll tell you what to write so that they can see.
I'm literally like coloring now the whole paper in. Can't you see it?
No, I can't
can
see
see it.
those.
Nothing.
I can see it this side. It's yellow.
Yeah,
Yeah.
I also see it.
I'm coloring the whole screen with yellow in. I'm gonna.
Now I can't see it.
Can't you
I
really?
can't see it.
It's now a red pencil. I'm scribbling over the paper. Can someone see
I
it?
can see it my side. I can see it.
Well, I can't. The only thing that I see is
How
the
come you can see
self-assessment
it? We
program.
can't see it.
Can you see the red now? Okay, can you see now the laser?
No.
Can someone see the laser?
Yes.
Yes.
Okay, then I think it's on your side the problem.
No.
Yeah.
Me and Kekana, we can see everything. Why?
I don't know.
Neither can I. Can't see.
Everything is still on. Kekana,
Yeah, sure.
take control. Did someone take control now?
No, I
What's
just
happening
did.
now?
I don't know what's. It's me.
Motsepe,
And
what's happening?
Can you all see my screen?
Yes.
Like the whole thing, even the side where it's meeting chat.
No, we only see a white screen.
Okay, let me try to open that. Can you all see what I'm seeing? Can you all see the content?
We
Or I
only
can?
see a whiteboard thingy here.
Okay, let me stop sharing.
Yeah, stop sharing the whiteboard. I have a thing for Kekana, lady. Just take control of the thing I shared.
Yeah, you were writing. Is it me writing or you?
We all can write on the screen.
Okay.
Wait, is it me who's sharing the whiteboard or something?
It's Motsepe. Just stop sharing the whiteboard, please.
Yeah, I'm trying. Let me do this. Okay. I'm close share 3, yeah.
Yeah.
Okay. Did you stop sharing?
No, it's still there.
Still there. It's loading now.
Okay, who's now in control?
Not me.
Okay, can you see my mouse?
No.
Uh, okay, can you guys see the laser now?
Yes.
So you all can see the laser.
No, I can't see the laser, bro. The only
I
thing
can
that I
see
can
it.
see.
Why don't you try leaving, then join again?
Um, Can you see the mouse?
No.
Can you try moving the laser again? I
Okay.
I
There's the
came,
laser
I
now.
went out and came back.
The laser is now on the screen. It's moving around.
Still can't see anything.
Seriously.
Yeah, the screen is still.
Stop sharing and share again.
Oh.
Okay. Do you guys see anything now?
Yeah, sure. Yeah, I can see.
Yeah, sure.
Okay. So any questions, someone? Anything?
Okay, what I was trying to explain the other time, you can use your mouse. Yeah, go to TAC, the TAC. Yeah, sure. Like when you compute TAC into I, J, and K, go to A, where there's A.
Hey, yeah.
Sorry about that. I'm having a network problem. Yeah, so you see that at
Hey,
at
hey there.
TAC, yeah, at A, ne?
Yes.
So if you are to check the TAC only in the X, ne? The X is that one. But then to compute TAC into the X-axis, the negative 0,408, the negative 0,408 in the I, it goes away from the X-axis. It goes away along the X-axis. No, the X-axis, yeah, it's that one. But then in the negative side.
Okay.
it's kind of hard. Ne? So, like it goes. No, you see that parallel to the x-axis.
This one. Because that's the x-axis there, and this one is the parallel one.
I'm sorry about that. I'm having another problem. I don't know how to explain this thing. As long as I don't know how to explain it because I'm not in control and.
Wouldn't you try sharing your screen or presenting your screen?
Thing is, I don't know how, man.
Mr. Butter, could you show him whilst like you're still showing, like whilst you're still
Okay.
on the screen? Could you show?
Sorry?
Do you all see now your names and stuff here?
Yes.
Okay.
Yes.
Then all that Kikana can do is this. Okay, now it's gonna say stop sharing. Or you must take control of everything. And you must just open the chats and click on this thing here. Kom maar so. Kikana, did you see what I do? Kikana? Kikana?
Yeah, sure.
Okay, now I'm gonna stop sharing, and then you're gonna do the same what I done just now.
I go to share content, ne?
Yes.
And then after that,
What do you see on your screen?
I see the screen, Windows 2, Microsoft Whiteboard.
Okay, put the Windows thing. Click on the Windows.
Then there's Mr. TJ Selowas, Thursday session, and there's chat Microsoft Teams.
Go to the chat. Wait.
But then it's fine, man. I think we can do another problem so that we don't waste any much of time.
I can share my screen and draw on the thing.
That's fine. We can do more of the problems. Try to explain them.
Okay.
Yeah.
Sure, because I can draw on it now.
Let's see. Maybe all of you guys can see now the laser or something. There's now a laser there. Do you guys see it now?
Yeah.
Okay.
Can you try moving it? No, I can't see it.
I'm moving it.
I ain't seeing anything. Not again.
Do you
I'm
see the
also
red?
not
Do you
seeing
see the red thing I'm drawing over the paper?
Nothing.
Nothing. Can you try to do the same thing you did last time? You stop sharing, then you share again. Because last time it worked.
No, man.
There's
What
a
did
big difference between sharing content and sharing the screen. Just share your screen.
Okay. Do you guys see now my screen?
Yes, 100%.
Okay. Okay.
Okay, so
Everyone see everything now?
Yes.
Okay.
so like, are we clear about this one, or like, should we discuss more about this problem?
Can y'all, if y'all don't mind, can y'all like start and explain it step by step, like how we are supposed to do this type of questions?
Okay, fine.
Like how do y'all do it when y'all see it?
Who, me?
Yeah, like just try to explain. Just try to explain what you did from the start when you saw this thing.
Okay. The first thing, Nick, you read the question and try to understand what the question wants.
Yes, the question.
They say that the light right angle boom, which supports the 400 kilogram cylinder, is supported by 3 cables. Now, I know that I have the mass, which is 400, and then I know that this thing, this boom, is supported by 3 cables. That's what I know. And then a ball and a socket jointed O are attached to the vertical X and Y surface. determine the reactions at O and the cable tensions. So one thing that I know again is that since we're at O, there's a circuit joint. I know that O has reactions along the X, the Y, and the Z axis. Then I'm done with the question. Then I can go to the solution now. I draw the free body diagram. Yeah, go to the solution.
So what they actually want there is just the components of that at that point.
Yeah, the reaction at O, the OX, the OY, and the OZ.
Okay.
Yeah.
And they also want the tensions. Okay. Yeah.
No, in order for you to get the reactions at OX, OY, and OC is when you can get your tensions.
Yeah.
I don't know, whereby you can compute the tensions into I, J, and K. And explain. Mr. Van Geffen, can you please go to the solution?
One.
Yeah, to the next one so that I can show you. So the first thing first, you can take any tension that you want to deal with. Like now I was gonna start with TAC the way they did. You see the TAC, ne? So TAC, you first look, you can just find the coordinates of A and C, right? And then like you can get the unit vector of TAC if you're having the distances in meters, right? Am I fast?
Okay, so what you did, you found the coordinates of A and the coordinates of C, then you subtracted them to get to be able to compile a unit vector. I don't know if you can hear me.
Yeah, I can. I'm having a network problem, so I'm sorry about that. I'm having another problem. So yeah, then you have to find the I, J, and K of TAC, ne?
Yes.
The magnitude of TAC, and then like you find the coordinates of A and then and of C, so that you can get the unit vector for TAC. Only to find that the distance between TAC along the I, it's minus 0.48. And then along the J, it's 0.408 J. And then along the K, it's minus 0.816.
Yes.
Then you're done. Then you're done with TAC, right?
Mm-hmm.
Same thing that we did in 2 dimensions. Then you go to TBD. You look at the tension of TBD. Only to find out that for TBD, for the tension in TBD, there's no I, there's no X, there's no X. You see that there's no X. X is 0. We don't have the I component. But then yeah. But then we have the J component, which is 0.707, and we also have the K component. The K component, which is the component that acts along the Z axis. You see?
Mm-hmm.
And then for TBE, for the tension in TBE, the one that is down there on your free body diagram, that's TBE. You can see that there's no, for TBE, we don't have X, we don't have Y, but then there's only there's only Z axis. There's only Z axis, which is K. Between B and E for TBE. And then after you're done doing that, once you're done doing that, then everything becomes sharp. Because if you go to the sum of X, the sum of Y, and the sum of Z, you know that for the sum of X, the only thing that you're gonna put is only the I. It's only the I. Those are going to be your sum of X. And then on your sum of Y, the only thing that you're gonna put there are the J's. For the sum of Z, the only thing that you're gonna put are the K's. You see?
Okay.
Yeah. And then after that, you look for the moments of everything that is acting on. First thing first, you look at the moment of X. So everything that acts along the x-axis, every force that causes rotation along the x-axis, you put it there. Everything that acts along the x-axis. And then on the y, everything that acts along the y-axis. Same applies to the z. And then once you have everything there, the sum of x, the sum of y, the sum of z, the moment at x, the moment at y, and the moment at z, then you look at the equation. the equation that can help you to get your tensions, that can help you to get the OX and then the OY. Then you're done. After you're done with the equations, the only thing that you do is the maths. And you take equations that can help you to get your OX, OY, and OC, and TAC, TBD, and TBE.
Okay. So
Yeah.
now I get the end process, you know, from after like how to find the sum of f of x. Now the thing which confuses me, ne, why do you all say there's no x? Can you just show me what the mouse why? Just like
For what?
for BD.
For TBD, why there's no I?
Yeah.
Because of zero. It's like the when we're doing.
Oh yeah, I see it.
Yeah.
I see it. Because
So
of both of them, they're gonna subtract each other. Okay, yeah, thanks.
Yeah, sure.
Yeah.
The 1.5 and the 1.5, I got.
Yeah.
Sure.
Now I see it. Okay, 1.5.
So now.
So now for BE, the x's are gonna subtract each other, and the y are gonna subtract each other.
It's
Okay,
zero, sure. Then the only thing that you're left with, it's Diden.
It's Z.
K. It's
It's
Z.
K. Yeah.
Yeah.
Okay. At least.
Yeah. Once you've done that, the only thing that you do is sum of x, sum of y, sum of z, and then for x you put the i's, for y you put the j's, for k for z you put the k's, and then no sharp.
Yeah. Yeah. Thanks.
And other than that, I don't know.
So can we also do? I don't know if everybody understands. You'll explain it much better.
Okay.
Can we do another question, or is there questions?
This is the last question of the slide.
Yeah, can we do that one for the stool? The secular, yeah, that one. Can I just explain the approach? Like, yeah, we read the question just like we did the last one. Please. Pretty please.
Mr. Van Geffen will do it.
Yes. You're already in the mood.
Or can we do that one, the 3.70?
I'll let him do this one.
Can somebody please just try to help us? Anybody? I think Ghana has left us. Oh, he's still there. Ish. Oh. Oh.
I'm trying to think how I'm gonna approach this one because I never tried it, so I'm just want to see.
Yes.
Mm-hmm. Can you go back to the question? Thank you. So the weight is not acting at the center.
Mm-mm.
Okay. You might want to grab this one.
Because this seems to be my problem. The 250 cos 60, that one seems to be the problem. Anyone who knows it can help. I got it, a discussion.
Can I share my screen?
Yeah, you can. Yes, you can.
Okay. Can you see my screen?
Yes.
Okay. Just check, yeah. You see me drawing?
Yes.
Can everybody see me?
No.
Can't you see the drawing?
I saw when you started, you clicked on the color, but now it's frozen.
Give your network some time.
Meh.
It might just be your network.
Yeah, but now it's working. Yeah.
Okay, so you can see me drawing now.
Yeah, now I can see you drawing.
Okay. So basically, we do is we want to figure out the distance from the x-axis because we are trying to work with the moment of the x-axis, correct? Okay, so we're just trying to get this distance from the x-axis to these legs because they say that the x-axis is parallel to BC. Okay, so you need this distance for the moment. So firstly, we need to calculate this distance from the midpoint of the chair to here. Let's say these are 120, so then this one must also be 120 right here. Meaning that this angle here should be 60. Okay. So then we just use cos, because this midpoint to the point of this chair is 100 plus 75 plus 75, that's 250. So you say cos 250 cos 60, then you get this distance. Okay. That's what they did here. 250 cos 60 is this distance here. Okay. Then plus another 250, which is from the midpoint to the x-axis. So that's where that 250 is. And the 2n, because NC and NB's upwards forces will be the same because they're an equal distance from the x-axis. So that's why they just said 2n. Are you guys following so far? Are you guys following?
Yes, we are.
Okay. So when we want to calculate the weight of L, just a normal F is equals to M times G. Then the answer is LG. Okay. So that's the weight we use. And L is in 75 from the center. So it's 175 from the x-axis. So we start by calculating the moment of that one also. That's this one. And the positive moment is always anti-clockwise, correct? But the L will try to press it clockwise. So that's why this one is negative. But the two legs with the N forces will push it upwards, causing it to go counterclockwise, which is a positive moment. That's why I say plus 2N by that formula. You just calculate and you find N's value. Then that's the force of each leg on this side. Then you can just take let me just see, did they give a weight of the stool as well or not? Or did they just give L?
Nah, they said you should neglect the weight of the stool.
Okay, so then the only then the net downward force is just L. So then we just take Fz is equals to 0, Na, let's see here, yeah, Na, L is equals to Na plus Nc plus Nb, because if every force is equal and opposite to reaction. So Na plus 2, these are these two forces, 2 times 2.3, 0.233 minus L as a downward force, you get 0. Then you calculate Na. Then that's the force on Na. Then you have all three legs as upward forces. You just work with the moment the entire time. You understand? Or where do you struggle?
Could you repeat one more time, but a little bit slower?
Oh, okay, sorry. So we are working with this moment on the x-axis, correct? Calculate everything like they did here. So to calculate the moment on the x-axis, we should take the force and times distance. And we want to calculate these two forces on these two legs first. Okay? Because they are the easiest for now.
Okay.
So we should first determine the distance between those legs and the x-axis. To do that, we should just calculate first this distance in this triangle and go straight across. It's perpendicular to the backside. Okay, to get the total distance from here to here. And they already said here that these angles are 120 degrees, 120 degrees. So then this one will also be 120 degrees because it's 360 minus 120 minus 120. Okay. And since these legs are all equally spaced from each other, this line will divide this corner exactly in half. So this corner here will be 60 degrees. So then you can just use the normal cos rule. Let me just write it out here. Let's call this length h, the length here, perpendicular distance. So you say h is equals to, and this distance is from the center point, 75 plus 75 plus 100, because it's ending there at the end of the circle drawn. So the total is 250 times cosine 60 degrees. Okay. Then the answer is, I'll quickly type it in, 125. Is this meters or centimeters or millimeters?
I think it's meter.
Meter. Okay. Oh, it has to be, because we have to use meters for the moment. But okay.
But then you see meter, don't like millimeter, they by the same.
Yeah, but let's just say it's a meter now, because I didn't give a unit. And it has to be meter
No.
for the moment.
I'm saying there, like, you see where the
Oh,
Z
oh,
is.
oh, I see. Let me just see here. Okay, let me just this out, like so. Okay, so this is, I could have just added, added the M. So this is 125 millimeters is H, that's small distance. Let's call this distance D from the x-axis to the furthest point where the stool will stand. The furthest point a force will be applied. So D is equals to 125 plus the distance from the center point to the x-axis, because we already have that one. And that one is also, and that one's 250, with this distance. 250 equals 375. Okay, so then we have this total distance here. Okay, so this is basically what I did here, the 250 plus 250 cosine 60. The answer within this bracket is 375.
Yeah.
And let's say 2n goes nc, write this here, nc is equals to nb, because these two stool legs are equally spaced from the x-axis, so they must be the same force. Okay, and this L is also in the center of these two, so it's not offset to one side, but it's in the center. Let's just call this N, like they did, to make it one force. So we have to incorporate both of them, because both of them are acting on this axis for the moment. That's why they say 2N. So it's the force 2N times the distance 375, which is equal to this bracket. And that's the upward force, and that will cause a moment that's anti-clockwise. And then we have to consider the weight of L, which is LG, or L times, oh, they didn't convert it, okay. So it's the weight of L times the distance, 75 plus 100 is 175, like they did here. There's a force L times distance. This one's negative, because it will be pushing downwards on the right side of the x-axis, causing a moment of clockwise, which is negative. So it's negative the clockwise moment plus the anti-clockwise moment is 0, because it's in equilibrium. Then you can calculate N from this I can't get on the word now, but from this formula I can say. So then you get N's value. Okay. So the total sum of the Z forces should be 0, and all three of these upwards forces on the legs combined should be equal to the one force of L acting downwards, because once again it's in equilibrium. So you just write this down, NA plus, so we're going to say upward is positive. That's why this is a positive sign. This one too, for the two legs. So upward is positive, downward is negative. So it's NA plus the 2 legs is forces, because this amount is only for one leg. I'm going upward. So you have to multiply it by 2 plus NA going upwards minus L is equals to 0. Then you can take everything over to one side. And you get NA is equals to 0.533 L. Then you get your answer.
Okay, thank you. I see.
Okay, do you guys understand, the rest of you?
Yes.
Yeah, sure.
Okay.
Can we just try
Yeah.
the 3.70 fast before the period is over?
Which one?
The 3.70. I mean, chapter 3, problem number 70.
Number 70.
Yeah.
Okay, I'll just have to check.
It's in there.
Yeah, I took a screenshot of this to draw on it. So.
Oh, yeah.
Yeah. Let me just see
How
which
do you
one
do a
it is.
screenshot with a laptop?
No, I'm on PC, but with Windows 10, you just press the PRT SCR button on your keyboard.
Okay, thanks.
Yeah, pleasure. Then I'll take a screenshot. Which number did you talk about?
This chapter, that one. You see that one?
Oh, which one? This one.
No, the one you were at. The
This
blue
one?
plate. Yeah, that one.
Okay. Just move this thing out of the way. I'm also going to take a screenshot of this one real quick. Okay, just find it here. Where is it now? Wait, let me redo it. Here we go. Okay. Okay, so is there a specific point where you are stuck, or do you just not know where to begin?
I don't know where to begin.
Okay, let me just get the question real quick again. See what they ask. Right. Given the tension in each cable. Okay. Go back to this picture.
Can I ask?
Yes.
Without looking at the answer, my approach would be like to look for the unit vector for each tension.
Yes.
Then after finding the unit vector, what I would do is just do the same thing which we did last time. So I want to see if we get the same thing.
Sorry? You're breaking up.
Yeah, you can try to explain it, please. Can you hear me?
Yes, I can hear you.
Yeah, can you just explain to me how you would approach it? Yeah.
Okay.
I got it wrong.
Okay, let me just quickly see here if they put in an axis. No, they didn't. Okay, you guys know how to make the unit vectors with the coordinates, or?
Yes.
Okay, so that's what we'll do first, because we have all the coordinates of these lines. So we can make the x-axis maybe from point A over to here, and the y-axis from A down here, crossing through B, and the z-axis from here up. So A coordinate is at 0, 0, 0. So then you can work from there to take all the coordinates into consideration, and then you can get a unit vector for all the cables.
Yes.
Let me just see if I can also take a screenshot of this, maybe. So I can draw on here. Okay. Let me. So okay, I'm writing with a mouse, so it's quite difficult. So I'm sorry. I'm sorry if it looks bad because I'm writing with a mouse. So
No problem. Now I'm the one who should be thanking you.
it's no problem. Okay, so let's start with the tension in AD, maybe. Okay,
Yeah.
so let's say DAD equals to DN equals to D times, like this. Okay, the first coordinate we're going to say maybe is, okay, it's also 0 because,
Yeah, 0. Yeah.
yeah, 0 minus 0 I plus, in the y direction, it is 0 minus 0.3 J plus, in the z direction is 0. Okay, this isn't really correct because I didn't give us the thickness of this plate. And you see it's 0.8 to the bottom of the plate, but the A is on top.
Yeah.
So we can just ignore that and still use the 0.8. So see here, again 0 minus 0.8 K over, again, even gonna write the I because it's 0. So minus 0.3 squared plus minus 0.8 squared. Okay. I think we should just first determine the unit, what do you call it?
They voted at the solution. I can see it. Yeah.
Yeah, because we don't have the force acting downwards, so we can't incorporate the T now. So this is 0I plus, just calculate the amount at the bottom. So square root, just to simplify things a bit, 0.3 squared plus 0.8 squared. Okay, so yeah, it's an odd number, so I can't really write it in. Okay, but so this is 0 minus 0.3 J plus, not plus, minus
0.9.
Let's see, 0.8. Yeah, minus 0.8 K over, then I calculated this bottom part is about 0.85. Okay, so we divide with each other. Okay, we should still put in I, so it's 0I because it will stay 0.
Yeah.
And minus the calculation
0.35.
0.35 I and J.
Yeah, 0.35 J minus
0.994.
yeah 0.94 K. Okay, this is the formula for AD. Just write this here. Three. Okay, then we have it for AD. Now we can take maybe EB will actually be the same because it's the same distance and everything. You can say N EB equal to NAD. But as you see, it will be the same distance, correct?
Yes.
Okay. So only one that will be different is F. But it won't have a I or J value. It'll only have a K value. So N of CF equals to 0.8 K. Was the rest is everything 0?
Yes.
Okay. Let me just try to think what I can do now. Okay. M.
Did you do BE?
BE is the same as DA. It will be the same length.
Oh yeah.
Yeah. You just think I trying to remember what I did from here. I can't remember if you should add up these formulas or not. Let's try to think.
Can I pick at the solution?
Yeah, I'm gonna do it now. Let's see. Okay, they used moments. Okay, 0.4 and 0.8, yes. Oh, and they incorporated the mass, mg. Okay. Mg. Okay. DCF. Oh yes, because DCF is the only one that will have an effect on the moment of y with the weight of the plate. Whereas the other ones are on the axis of y.
Yeah.
So the sum of the moment of y is 0. So mg times the half of 0.8 because it's the center of mass in this plate. So 0.4. Like they said here.
Oh, that's where it came from.
Yeah. The center it's always the center of mass. So in other words, it'll be 0.4 from the y-axis, and let's see what this distance is. 0.3, but this is 1 meter across. So
Yeah,
it's
so
0.5 from the side.
Yeah, because that was what was confusing me. Like, how am I gonna include the weight in the moment? Yeah, thanks.
Oh yeah, you just do it for the y-axis. For the x-axis, you just they take the x-axis on the other side. I did mine on front, but it won't matter. So you see here 0.5 mg. Oh yeah, 0.5 is the same distance, 0.5 and half mg. You see what I did here. Let me just first check if my formula here is the same. Minus 0.35 and minus 0.94. Yes, okay, it's the same here. And yeah, the E was also the same, just a different. Oh yeah, I forgot to say, this one will be a different sign at front because it's going the opposite direction, as you see here. Right, look, where's the answer now? Yeah, because BE is being pulled in the opposite direction of AD on the y-axis. The y-axis component will be a different sign. I forgot about that one. Okay, so mx. Thing is, I only knew how to do the units, but I still don't really know how to do the moments. Because this one is quite a difficult one. Let's see what they did. I'm just trying to figure out why they said half of mg here. Sorry?
Attention of TCF.
Sorry, your line is unclear.
Attention of TCF.
Oh, I see. Yes.
Yeah.
Okay. Oh, that makes sense. Okay, so it's also 0.5, got 0.5 away from the x-axis, and then AD you can calculate with the unit formula by yeah. Just see if they did it. It's weird that they didn't do it. That's weird. Just see here. DAD 0.936. The K direction. Oh, I see what they did. Okay. They took DAD's Z component. Yeah. Okay. Because that one will have an action on the moment of the x-axis. Now I understand it. That's why they took the Z component of DAD and multiplied it by 1, which is this thing is 1 meter across for the moment of x. Yeah, and those three are the only ones that will affect the moment of x because the third cable is on the x-axis. Okay, and you can calculate DAD. FZ is, just see here, half mg. Okay, again DCF. Oh, okay, there's a force, yeah. So there's just plus the TCF and the Z components of DAD and the Z component of TBE, basically. But they are the same, so you can just put them as one here. 0.27, yeah, DAD. You can see they're the same thing. So multiplied by the Z component, 0.936. Well, that's the force that goes upwards. Okay. Or the distance, sorry. And so, as you can hear, I'm also quite unsure about this one. But if I look at the answers, I can understand what they did and why they did it. But if it's in the test,
That's the funny part.
yeah,
I understand it, but will I be able to apply it?
yeah,
But I think practice is the key.
that's the thing. I still don't really know whether I only took one of the components here. Huh. And why they multiplied it by 0.936.
Okay, so isn't it the angle? But wait. No.
But the thing is, I took TCF's value just as is and plussed it. So I don't know why they did DAD. Oh, I understand. This 0.267 is a total force in the diagonal cable. So in the cable itself, it's not a component, obviously.
Oh.
Yeah. So so that's why I multiplied by its Z component. Yeah. That's why. So you multiply by the Z value to get the Z component of it. Get the force on the Z axis. So they're basically saying this output force plus DAD's output force. That's what it is. And oh, here it is, TBE. I was wondering where it was. So the other side as well. And same for this one. TBE's force in the Z direction. So multiplied by 0.936, the Z component. And minus mg.
Okay, so what's confusing me is how did they get the 0.936?
Sorry?
How did they get the 0.936?
Is this for the unit formula? They took the Z part. component.
Yeah, so since because all the unit vector multiplied by the force. Yeah, okay.
Yes.
Oh yeah.
Because
Thanks.
this number here is equal to the force in the cable itself.
Yeah.
So you have to calculate the force in the z direction of this cable, z component. That's what I did here. Z component of the unit multiplied by the force in the cable, and you get the z component. And the same on the other side as well. But we don't have TBE yet, so they just said TBE multiplied by this. Then you can calculate TBE. Then you have all the cable extensions.
And I almost forgot about MG.
Yeah.
But thanks, bro. Hey, at least now I see the light. At least I understand how they did this one.
Yeah, I still also have to practice a bit, but it's getting better. So you just have to
Yeah.
practice.
Thanks. Now I'm going offline now.
Yeah, me too. Okay. There's not many of us left anyway.
Thanks for the hard work.
But I think we can call this a day.
Yeah.
So yeah,
All right,
cheers.
guys. I
Okay.
stop the recording now.
Okay.
Cheers.